Hello, my name is Miao. My final project is some experiment with word embedding. What is word embedding? See this picture. The word cat, dog, and car are in a vector space. A lower dimensional dense vectors for words are called embedding. Vector space mode. There are three ways to represent a word as a vector: the word in a document, the word in a context, characters in word. For this one, we can see the word banana in doc 2, doc 4, doc 7, doc 9, doc 11. And the second one, banana, in the sentence, yellow banana grows on trees in Africa. And the third one is the character trigrams for the banana. CBOW and skip gram mode. The CBOW mode is continual backoff word mode. It uses the average embedding of the context words as a context representation. The skip gram mode uses one of the context words as the representation of the context. GLOV mode. Global vector mode is based on the word context matrix. Its row corresponds to a word and its column corresponds to a context. So the element in the matrix is corresponding the word and the context. My experiment and the results. Here I have done 3 experiments with word embedding with the three modes we have talked about. The first one is modes comparison. The next one is get most similar words. The third one is Twitter sentiment classification. In the first experiment, I have used different curves to evaluate the 3 modes performance and accuracy. Here I use these 3 curves: text 8, OANC, MASC. Use these different sets of curves. The text 8 has the largest vocabulary size, and the MASC has the smallest vocabulary size. And I use the word window size equals 8, the training thread equals 20, and I use the dimensions and the iterate parameter like this: 215, 230, 50 and 15, 50 and 30. I put the result in this table. We can see the result. GLOV have the fastest speed, and the skip gram has the runs slowest. And we can see the result here. The CBOW mode has the best performance, has the best cost performance, and in generally we can see increasing curve size or vector dimensions or number of iterates can improve the module's accuracy. We can see here is text 8. For example, text 8 accuracy is about 53%, with dimension 200 and iterate 15. And if we increase the iterate to 30, the accuracy is about 55%. So we can say if we increase the cop size of the iterate, the number of iterates can improve the accuracy. The next experiment is get most similar words. In this experiment, I used the CBOW mode to find the most similar words with a given word, and analyze the relations of different type of words in vector representation. For example, given a given word is good, run this script, I get the result. Bad is the most similar word for good. Lucky is the next. And we can see the picture here. The blue point is the most similar word for good. For trying to find the relations, I use 3 different types of words: good, apple, and boy, and draw their most similar words in one picture. Here we can see that words with the same attributes are together. The last experiment is Twitter sentiment classification. Here I use Twitter dataset. For more information, you can find in my write-up, and you can download it free from the internet. I use the first 8,000 data as a training set, the next 2,000 data as a testing set, and then I build the CBOW mode and use TF-IDF to as a weight to combine the word vectors together as a new one to represent a Twitter sentence, and then feed these vectors into a neural network classifier. Here I use a 2-layer neural network architecture. You can see the input is 200 dimension, and this input is CBOW's output, and the final is output 0 to 1 classifier. At last, I get accuracy on the testing side is about 84%. So that's all. Thank you very much.